Hi, everyone. Welcome to today's webinar on DEWETRON's latest software update of Oxygen 7.6. Thank you for joining us today. I'm Gabriella Scott, the marketing specialist at DEWETRON, and I'm joined by our senior applications engineer, Corey Clark. How's it going, Corey?
It's going really well, Gabby. Thank you for the introduction.
Welcome. So before we begin, we'd like to know which version of Oxygen you're currently using. So please take a second to participate in the following poll that just popped up, and we'll give you just a few seconds to respond. Okay. Great, thank you. There are a few quick things that I'd like to mention before we begin with the training. So first, we love your feedback. So stick around until the end of the presentation to take just a quick survey. Also, like always, if you have any questions during the webinar, feel free to ask them in the chat at any time. We always follow up with viewers afterwards if you have any questions at all. Okay, let's get started. So with this release comes lots of interesting new features. Corey, could you give us an overview of what to expect?
Yeah, sure thing. So within this presentation, we'll talk about the new features such as the new 3D plot instrument that we've implemented. We've added the ability to do live reference curves during your measurement and also in your data files. We have added the capability of exporting channel configuration information from Oxygen to third-party software. We've developed a frequency tracking filter for those doing order tracking or other types of vibration work. We've done some improvements to our XY plot. We've added some power improvements when it comes to some of our instrument display that we have, and then we've added some new channels to get us in line with a standard that's out there, and then we've improved our resolver offering as well. Along with all these other previously mentioned features, there's some additional export add-ons, some really cool new math functions that have been added to the software, which should be helpful. And there's, of course, at the end of these webinars, we always go over some of the miscellaneous features, the bug fixes, and some of the new features with our drivers, as well as the bug fixes for our drivers as well.
Okay, great. So it sounds like we have a lot to go through. So to start, could you tell us more about the 3D plot instrument feature?
Sure thing. So the new 3D plot instrument, it's just a new way to visualize your data in 3 dimensions. So with this plot, you can do, you can rotate the plot, you can zoom in, you can add cursors or put a cursor down to get different information out of the plot itself. This plot supports array channels. So if you've done some CPP analysis or you have harmonics from your power measurements, these can be used in this plot. But mainly this is typically used for vibration work. So for order analysis channels that we can plot in here, and our accelerometer channels as well. So this gives you a lot of different ways to visualize and navigate through the data. And I have a demo file available to show you what this display looks like within the software. And so I will switch over to that file, and I'll just stop sharing this. And so on the screen, we can see we have a chirp function, and we could see it in our spectrum analyzer here in the frequency domain. We also got the signal in the time domain here in our oscilloscope view. And then we also have our spectrogram view, which is our time-based way of looking at the frequency spectrum with a z-axis as well. So to the right of this spectrogram is our 3D plot. And on this 3D plot instrument, we can right-click and move around to visualize the data and rotate the instrument as we'd see fit. We can left-click and move the instrument around as well. And then you can, of course, scroll up and scroll down to zoom in on this instrument. You have the ability to also click within this instrument to set the cursor position and then get a readout of the values that are actually at the position itself. Some properties of this plot is you get to set the color sequence that you're working with, and then for the z-axis, and then you can also set a time span for this plot as well. So right now it's set to 10 seconds, but you could set it all the way down to 1 second, just to basically set up how much data you want to look at within this visual display, as well as if your PC is running a little too hard, you can lower that as well to make the system run a little smoother for you on your computer. And so that is the new 3D plot instrument.
Okay, thank you. So to summarize, with the new 3D plot instrument tool, users are able to visualize various array channels and spectra in 3 dimensions. So it just gives users a new visualization and way to view their data.
Yep.
Right. Okay, great. Next in line, we have the time reference curves. Could you share more about this feature?
Yeah, so the time reference curves, it's a new capability added to the advanced math section. These will build curves in the time domain for you. So these time reference curves can be built manually. You can we'll show you that on the next slide, or you can actually pull in a previously recorded file and pick a signal from that file, and then use that as your actual reference curve. This reference curve can be triggered to start in a couple different ways, and these are for visual reference only right now. However, these could be eventually changed to be something that when you exceed the reference curves, we can enact something in the software, just like a trigger. All right. And so now to work with these reference curves, it's pretty straightforward. You just go to the advanced math section and add this to your channel list and jump into the setup for it. And so in here, you could define a single type reference curve or a 2 reference curve setup. So you have upper and lower limits. The data source, which is the second option, can be based on table values. What you see to the right here with the plus button, you can simply add different sections for different time values and amplitude values. There's also a paste button in here. So if you had a reference curve already set up in something like Excel, you could copy it there and then hit the paste button to implement it right inside of Oxygen very quickly and easily. You can set up a fill ahead time so that the reference curve is drawn as your test is running, so you can actually visualize that live. And then you can basically set that fill ahead time to be up to 500 seconds in advance. There's also an end behavior option, and the end behavior can be set up to basically loop that reference curve, so it continuously replays, or it can be set to output the last value that was a part of the reference curve, or just simply start outputting not a number. And then there's also abilities to start the reference curve. So you can start the reference curve upon starting acquisition, which is what happens when you open Oxygen. We're just acquiring data, so you could start the reference curve there based upon pressing record, or you could set up a trigger condition to start this reference curve for yourself. And then in the bottom right-hand corner here, we can see a nice visualization of what this reference curve looks like inside of our recorder instrument, and it sets a nice boundary for the white signal that's within the instrument itself. And that is the new time reference curves.
Oh, great. So this feature sounds really helpful because users now have the option to, like you said, create 1 or 2 reference curves and apply those to a live measurement during the recording. So it's a great feature to have accessible. Next, could you please give us a closer look at the channel configuration export feature?
Absolutely. So the channel configuration export, pretty straightforward. Inside Oxygen, we have our channel list, our data channels menu, and it's a nice table display as shown in this picture on the left-hand side. And so in this channels menu, we can use the left-hand tick boxes to select the channels that we'd like to work with. And so once we've done that, we can just do Control-C, and then we jump to our third-party software. In this instance, in the image is Excel, and just hit Control-V to paste. And once we've done that, all of that information will be pushed to the third application, and it can be saved. This is great for maintaining records of what the settings were for the channels. This is something that's built into Oxygen. When you look at the setup files and the data files, you get this information, but it was not outside of the software. So sometimes we need to retain records separately from the software itself. And this is just a method of helping to get that done.
Okay, really cool. And that will help users just to document everything they need within the tool in a more efficient way.
Yes, exactly.
Great. Now that we've covered that, let's take a look at the frequency tracking filter.
Awesome. Yeah, so we have a couple slides here, and then I have a demo file to show you as well for this. So the frequency tracking filter, it's a really nice tool. It's basically a adaptive bandpass filter. So bandpass filter is going to come down, has a center frequency, and it's just going to attenuate signals outside of the bandwidth of the filter itself. So with this filter, since it's adaptive and changing, the center frequency needs to be tied to a reference speed signal. That could be in RPM or Hertz. And so as you run your motor up and down, the center frequency of this bandpass filter will be changed with the running speed of the device under test. And so with that, you can then tell the plugin for this frequency tracking filter to extract the orders or specific orders of the accelerometers that you've tied to this plugin. So as the motor ramps up, we are going to capture the values from the accelerometers as per those extracted orders. And so on the second slide here, you can see how that is actually set up. So the first field here is our acceleration, our input channels field. And in here you click the box and you get a list of your channels that you're going to select from. And in here it's just a simple acceleration channel. We have our reference speed channel. This again determines that center frequency of that bandpass filter. And then we have our fixed bandwidth for the filter itself. We're able to set the filter type in order. So it's going to be Bessel or Butterworth. And then we have anywhere from the second order to the 10th order for the filter itself. Now for extracting the orders, it's as simple as just keying in some values in the extracted orders section with a semicolon in between. And so for this example, they're extracting the first, 2.5, and fourth order of the acceleration signals. And so as a display image, this is what it looks like. And so this will be the demo file that we'll look at quickly here. And so I will switch over to that file now. Okay. 1 second. Here it is. And there it is. Okay, great. All right. So within the data channels menu, once we open this up, we can click on the plus button. And in here, you can see the underneath filters, we have frequency tracking. It's blank here because you just have to hit add. And once you hit add, it'll add this section underneath local node. It's called frequency tracking channels. So under here, we have our frequency tracking filter set up. And in here, we can just see exactly what we saw in the previous PowerPoint slide. We set up our input channels, the speed reference for the center frequency of the filter, the fixed bandwidth of the filter, the type, order, and then the extracted orders. Okay. Once we set up these extracted orders, it'll give us several channels below for however many orders we are extracting. And you can see the order information is tagged at the end of the channel name. And these channels are now available for us to display. And they're also recorded to disk alongside of our analog channels. And so if we hit play here, let me move this little pop-up. And we can see here in our time domain display at the bottom, and then our spectrum analyzer at the top here, we can see our signals. And inside the spectrum analyzer at the top, we have our acceleration signal in blue, the raw one, and then we have the first order, the fourth order, and then the 2.5 displayed as well alongside of it. And then you can see this information down below as well in the time domain. So you can see the raw acceleration signal and then the extracted order information for that same accelerometer signal. And this is all based upon the running speed of the device under test. Okay. All right. Thank you.
Great. So it will really help users by automatically locking onto the frequency components tied to machine speed, so they don't have to manually adjust any filters. So it's a great feature to have. Okay, moving forward, can you tell us a bit about the new XY plot improvements?
Sure thing. So XY plot has always been something that's been in Oxygen for a long time, and I will share my screen here and get this presentation back. And so the XY plot, it's a nice tool to use within the software. You can handle multiple signals in here. And basically, it was just a standard XY plot. We'd plot the points upon the display. Now, what we can do, we've added the ability to add reference curves, which seems to be a theme throughout this update. So now we have reference curves within the XY plot. These are just visual boundaries, as stated in the slide. We did mention in the previous reference curves where we, in the future, may be able to do software changes based off of exceeding those limits, but here these are just visual. Inside the XY plot itself, we can pin data labels, which you can see here is number 2. So you just click on a trace and it'll give a data label in here. That data label is persistent to the instrument itself. So once the instrument's deleted, it's going to disappear. But it's a great little ability to copy that and put it into a report page based inside the software. And then we also have the ability to now add A/B cursors to our XY plot as well. So we can get the delta information between those two cursors or any point on the traces within the plot. Now, also over where your mouse is pointed, there will be a crosshair. And that crosshair, wherever it's laid over, will provide that signal information. Both X and Y values in the upper left-hand corner of the display as well. And I have a demo file for this to show you as well, just to show you some of the stuff in action inside of the software itself. So let me switch to that as well. So inside of this simple file that I have here, running some simulated data, to draw a nice pattern inside of our XY display. I've added a few reference lines to draw a reference box or reference curve around our image here. And it's really easy to do all this. So all we have to do is in our XY display, we double click on it. And then in that brings us right to the properties. And below the X-axis section, there's a reference curve section. In here, you can add as many reference curve sections as you want to build the specific curve or box or line, whatever you need to build within your XY plot. This will set up something for you to set the width of the line. You can set the color of the line as well. And then you can click on edit in here and start to build your line within the XY display. Just note that there is a paste button. So just like all the other times we work with one of these little table builders, you can take something from Excel and just paste it directly into the software itself. All right. To remove these lines, super easy. Just click the minus button and then you're good to go. And so I've built several lines here. So to edit, it's just simple XY coordinates, and that will get your line built for you. Additionally, in here, we can add data labels. I have a couple on here, but to add these is incredibly easy. So we just find a point on our trace and left click. Let me turn this cursor off. And then left click onto this point, and it will place that data label that you can pick up and move around. And you can have as many of these as you want. There are no limits here. And you can then take a screenshot or copy and paste this instrument into PowerPoint or to your reporting section of the software to build a PDF report. Additionally, we also have the cursors. And so in here, we click the cursor button. It brings up our cursor box at the bottom, and we can just highlight a part of our curve to place that cursor and then place the second cursor. And that will give us a delta value between A and B right within the cursor box itself for us. And just remember what I mentioned earlier, these data labels, they're persistent to the instrument itself. So once the instrument goes away, the data labels all go away. So just be sure to remember that so that you save this instrument, don't delete it on accident before you use it for reporting. And that would be the new XY plot improvements in Oxygen 6.
Okay, awesome. So this feature would definitely help engineers during testing to visually see if a signal exceeds a reference curve, and that's important.
Yes.
Okay, next we have power improvements.
Yes. So there's been several power improvements to the software. There's a couple slides here to go over. So the first slide here goes over the improvements to our visualization for the power groups. So if you do power analysis, you can grab the power group, drop it to the measurement screen, and you have several buttons you can see in this display visualization, several buttons in the upper left-hand corner. And we've always had our table, our vector diagram, and we also have these harmonics displays for voltage, current, and power. Recently, if you saw our last webinar, we did an update where we added some capability for flicker measurements with a nice flicker display. We kind of took that and did it for our harmonics display as well. So now we can set limits for the harmonics within the display. And if we exceed the limits for any of the orders for the harmonics or the interharmonics that we set for these displays, the display will update live and provide you with red text to let you know where the excessive reading came from. And over time, we track the maximum RMS over limits that are sensed on any of the orders for the harmonics channel. And this maximum RMS over limit is given a timestamp, and it's displayed proudly in the display at the top. So you can see where number 5 is on the screen. It looks like a little hyperlink for your time, and you can click on that time value, and it will jump you to that specific moment in your data file. So when you're reviewing the data, it's pretty easy to find those points of interest using the harmonics limit table. And these limits, they can be dictated via the instrument properties and clicking on the edit button in there. And you can set the orders to see in the table and then the limits for those specific orders. Of course, it's another table display, so we have that copy paste feature available, as I've mentioned several times already for this presentation. So I have some demo data for this, and I will show that to you now. Some of the capabilities of the limit table. Okay, so on my screen, you can see I like these tables. There's a lot of them here. So we have our harmonics table, and then we have interharmonics table below that. In here, you can see we're looking at the orders from 0 to 10. And then we have the limits that we've established in the instrument displayed as well. We can see the maximum RMS seen at any point in time during this measurement file, and that's displayed as well. As well as your phase angle, your percentage of fundamental, your RMS values. We do have a nice overall all limits information for passing or failing as well. And in this center display at the bottom here, you can see previous max RMS over limit at 921, 929, and I can click on that, and you can see our time flag has jumped up to 921 here for us. So it's a nice way to find out when limits failed and then to easily navigate to the point in your data file of where that limit failed, so then you can scrutinize the other signals. For setting up this instrument, it's really straightforward. Just like all instruments, double click on it, brings you right to the properties for that instrument. Now, in here, you can see if you move down, you see harmonics tables. And for each of these tables, we could dictate how they look and how they operate. So for this table, we could say show orders. It's set to all, but we could set it to just show odd or even orders. And then we can say, I want to show harmonics, interharmonics, or both. And then we can change the look and feel of this table display. Just because, remember, this table display is not just for visualization, it's for reporting as well. So if I want to, I'm going to come in here and blow up the table display to full screen. And if I want to change my columns, I can do that. So I'll say 6 columns, and it will change the way this table actually looks. So if you wanted to make it look nicer for your report, you can easily do that. Alignment as well, reporting purposes and visualization purposes. And then we can choose what to show and what not to show when it comes to percent of fundamental, phase angle, and the RMS levels. For harmonics limits, we can show the limit value by checking that box, and it puts the limit value in the far left next to the order number. And then we can show the max RMS level as well. For the RMS calculation, we can dictate the RMS calculation here as well. So it can be done in a window from 0 minutes all the way up to 120 minutes. So it should fit for a lot of different requirements there. And now, as I mentioned before, depending on how you set up your power group, you'll have access to voltage, current harmonics, and then power harmonics table. For this one, it's voltage and current. And we can see down below here, we have voltage, current, and power with an edit, copy, and paste section. And in here, I can click edit, and it brings up my nice little table. And it's going to reflect the orders that are seen here on the display, and also the limits that are associated with those specific orders. As I mentioned during the slide presentation, you do have the copy paste buttons here as well, which should help you efficiently build up these tables for your test. And that is the new improvements to the harmonics limits tables. And there on this next slide that we have to go over here as part of the presentation, there is another addition to the power improvements. Our friends are leaf blowing outside. And so the PowerPoint slideshow. And so now on this next slide, we've added some new channels and calculations for the power groups to align us more with the later revision of FGW TR3 to bring us into compliance with it. And these changes are included in Oxygen Power Basic. And so these just add additional symmetrical component channels for voltage, current, and apparent power. All right. These will also be available to you if you have Oxygen Power Expert option as well. One additional improvement that we have here is also an improvement to our plugin for our tape sensor resolvers plugin. Before, for resolvers, we just supported one pole pair, but we've added a new field and some new calculations behind the scenes to support multiple pole pairs for users that want to improve the angle resolution with more pole pairs. We can definitely support that.
Okay, great. And quickly before we move on from Power Improvements Core, we actually got a question in the chat. Someone asked, will the limits being exceeded trigger email, text, or similar alerts?
No, these are display visualizations.
Okay, great, thank you.
But if that's something, something that's important, just, let us know. We'll talk to the team about it and see what we can do to implement something like that for you.
Yeah, absolutely. Okay, so next there are some new export add-ons as well as some new math functions. Can you tell us more about these additions?
Yeah, so The export add-ons, there's only a couple here. And for MATLAB, basically, this came from a client of ours. When doing the MATLAB exports, you would get your channel information, your channel name, the units, the sample rate, and you wouldn't get any scaling information. That's been updated. So now when you do a MATLAB export, you'll get the channel configuration information as well for the scaling. So you can see that in the image here with number 1. And our second update for the exports is an add-on to our native Excel export, so the XLSX format itself. There's a new tick box in there to export the header fields as well. Within Oxygen, we have the ability to do headers, so we can add formula constant headers, we can add a multiple choice header, so you could pick like names from a list for different users, and then we have a simple text header as well, so you could use a scan gun to bring in like the serial number of a device under test. And these headers are all things that can be set to be filled in upon starting a recording or stopping a recording. And so all this information, it lives as metadata inside of your data file. And it's all searchable inside of Oxygen, so you could search for specific files for specific devices under test and all that. Now you can actually get that header data out of Oxygen and into your new XLSX export. So when you do the export, you'll actually have a separate worksheet for you at the bottom of Excel. And it's called header data, straightforward, easy to find. And once you click on it, you'll see everything associated with that data file as far as the headers go.
Okay, great. So these new features seem really helpful for those using the MATLAB and Excel exports.
Yeah, it's just a nice way, just like we mentioned earlier with copy and pasting the channels from the data channels list to Excel to get the channel information. This is kind of following that same track, but just adding it to the MATLAB export.
Okay, great. And next we have new math functions.
Yeah, so the new math functions, they live in two separate sections of our formula creation screen. If you've used our formula creation screen, you know we have a little, looks like a keypad with arrows on the left and right, so you could flip through pages of that. And one of the pages is called generators. In here we have time and measurement time, generators, and now we have the ability to actually generate chirps, sine waves, cosine waves, sawtooth waves, triangle waves, pulse waveforms. We could delay samples, and then we can do a linear interpolation between two signals if we need to do that. And these are nice to have within the software, so you don't have to manually build these waveforms based off equations anymore. You have a nice simple function to work with, and it really makes it nice for when you're developing a setup and you may not have the hardware available. You might be on your laptop and you want to create a couple of nice waveforms to develop some triggers or some event-based recording features within Oxygen before you get to the actual hardware itself. So it's a nice feature for simulation and signal generation.
Okay, perfect. And we've also added many miscellaneous features as well. Can you take us through these?
Yes. So miscellaneous features, aka quality of life features. So number 1 on the list is the digital meter. So Oxygen has always had digital meters, and we have the ability to change the color of the numbers or text inside of our digital meters. We could set the upper and lower limits. It would be a nice visual representation for the client or user to see if a limit's been exceeded or not. Now, sometimes that can be hard to stare at, these numbers flashing and changing all the time. So we have the ability now to actually set the background color of the instrument itself. So it's a little bit easier to see for the user, especially if they have a lot of different digital meters. They can see it flash a bold color for the background of the meter instead of just the number itself. Don't worry though, your numbers can still change color. You can get a lot of flashing going on if you're not careful. So just be aware of that and take time to set that up. It's a great feature. I'm glad it's in the software. One of the other really nice software features we've had, software hardware features, is the ability to divide our sample rates. We do it a little different. So we don't just, when we do sample rate division, we don't just throw away samples. We actually set up the filter properly for the channel, set up the ADC for the new sample rate on that channel to give you really good recording. And before, when you turn this on, you only had several sample rates to select from when you were dividing down. We just increase the amount of sample rates you have to select from now. So you have a lot more freedom of choice within the software for a target rate when you do enable the sample rate reduction. Another miscellaneous function or feature is tied to our A-Ring 429 offering for our users out there making use of that. The ID values can now be interpreted as octal values. Small change, but it's there now for you to use. Additional miscellaneous features have to do with our synchronization capabilities with the hardware and software. For a long time, we've supported iRig and PTP synchronization. But in the software for iRig sync, we always just use our, the standard term for the iRig code. So like code A, AC, code A, DC, code B, AC, etc. Right? Well, there's specific codes to go along with these for specific iRig codes. So we've added those as well. You can see those in the image right next to the number 4 here. So these specific codes are referenced. So they'll be in there for you. Just helps make things smoother, eliminates any kind of questions or second guessing within the software. And for PTP synchronization, we've added the domain information there as well. So only the default 0 domain is supported. It's just more information for the user so they can make a better use of the software for when they're doing setups. And then for outside of the synchronization side of things, we have something called data stream, which is the ability to pump data out over TCP/IP to another device or third-party device so that it can be decoded, displayed, or just stored in a repository. This was a Skippy command to kick this off and start it. So we can actually start it now by using absolute time. So we can say, I want, for this example here, January 1st of 2026 at 12 o'clock, I'm starting my data stream. And so we could set that up to automatically happen now. And then we also have a update to the FIR filter creation screen. And inside the setup screen, we can now see the output sample rate of the FIR filters based upon the stage setup. And so that will be helpful for the end user as well. Now, further miscellaneous function features, I keep saying functions, features that are available within the software will be FFT frequency weighting. So this is shown in the images to the right here. And so you'll notice that on the far right, this is our spectrum analyzer instrument. So within the instrument, we do have frequency weighting now as well. And then in this image here, number 8, we see the frequency weighting added to our FFT math channel. So the FFT math created using the plus button in the data channels menu, you can add frequency weighting to that. So anybody doing some sorts of audio analysis work will have that available to them. This is one of my favorite updates is number 10 here. So you now have a warning within the software when you're about to delete math channels. So if you have ever in the past clicked a checkbox and forgot to unclick it and accidentally deleted a math channel, you won't be doing that anymore. You get a nice pop-up that will be displayed to you listing all of the channels that have been selected for deletion, and you can now back out of it, which is incredibly helpful. And next one, number 11 here, is when we have a mode for our cards that will allow you to monitor the current and voltage excitation of the card itself. So if you want to make sure that the correct amount of excitation is being provided to a sensor out in the field, we can do that with this measurement mode. So you can actually see and measure the value there. Before, when you did this, you switched from voltage mode to the monitor mode, you'd have to set up your excitation settings again, which just led to redundant work and a less efficient process. So they've improved that by just keeping the excitation on as you switch the modes, and so you don't have to redo that anymore. Really helpful, nice little efficiency fix. Bug fixes, we have bug fixes in Oxygen and for the TRION drivers. So the Oxygen 7.6 bug fixes, there was a crash that was being experienced when loading a simplified XML setup file that's been squished. Acquisition was being restarted automatically on a mode change. That's been fixed. We have a function with our Skippy feature set called elog, which is a buffered data set query and retrieval. That would time out under specific instances, and that's been addressed. And then also for our users in the automotive space using XCP with Inca or Canopy software, there were specific instances where data transfer would not begin, and that's been fixed as well.
Okay, great, thanks. And then last but not least, we just have a few TRION 3 updates, some new features and bug fixes here as well.
Yeah, so here on slide 19, we have a surprise. So TRION 3 CAN FD board is coming. So this is our latest generation CAN offering. It's a 4-channel CAN board that offers capability for standard CAN 2.0B, J1939, etc. But it also supports CAN FD now. With that, with this new board, in the channel list, you'll have a lot of different channels available to you, not just the standard CAN interface channels, but you'll have a lot of status and debug channels available to you as well, which should be very helpful. And for the configuration, you'll be able to set your baud rate high, of course, your termination and timestamp as we've always done. And then you have some advanced features as well that'll be built into the channel setup for this new CAN board. Data sheets are available. If you'd like one, just let us know and we'll get one sent out to you. Now some TRION bug fixes. We were made aware of a slight issue with some timing from firmware, and this bug has been fixed. And then we had a small clock issue with the light PA controller that had a firmware fix implemented that corrected this. Our TRION power board, the counter time base has been adjusted and set to 100 megahertz. This has been a trend now. Our boards have all been getting this treatment to improve the time base of the counter. iRig now reports the same correct timing code, which we discussed in a previous slide. The excitation voltage monitor and current monitor excitation settings are now fixed. So when you switch to those modes, they won't disable excitation, etc. And then for our TRION SDK, which anybody can download for free, by the way, it's open to use. And so you can build your own software application using our hardware. There's a function in there for DEWE read CAN EX, and that function has now been deprecated. And that brings us to the end of the bug fixes.
Okay, great. So that also brings us to the end of the webinar. So thank you for taking the time to join our update on Oxygen 7.6. We really appreciate your time, and a huge thanks to Corey for showcasing the new capabilities. If you have any additional questions, please feel free to reach out to us and we'll follow up with you as soon as possible. Also, as a reminder, we love your feedback, so be sure to take the quick survey at the end that will pop up in a few minutes. And thanks again for joining us, and have a great rest of your day.
Thanks, everybody. Have a great one.